Good day, guys. In some time ago, we started scalars and vector quantity. You can still remember scalars and vector quantity. So in the last class, we explained about scalar quantity, and we said that a scalar quantity is a quantity that has magnitude only but no direction. It means that direction cannot affect a scalar quantity. A scalar quantity is independent of direction. For example, if we have a mass of 50 kg, if I take 50 kg to the moon, it will still remain 50 kg. The moon do not have any effect on this quantity, on this 50 kg. Are you getting it now? Why? Because first of all, mass is a scalar, and scalar is not affected by direction. But when we begin to talk about vector, for example, we talk about weight. The weight of a body, which is 50 Newton, when that weight gets to the, for example, we have a weight of 50 Newton. When that weight gets to the moon, it will no longer be 50 Newton. It will change. The value will change according to the gravitational acceleration of the moon. As time goes on, we begin to talk about gravitational acceleration of the planet. But the value, the force on the mass, the force, which is the weight of the body, will change when it changes its direction. Are you getting it now? Now, those quantities that changes their direction as a result of their magnitude as a result of their direction are called vector quantity. So let's begin to define vector quantity. What is a vector quantity? What is a vector quantity? A vector quantity is a quantity. Write it down. A vector quantity is a quantity that has magnitude and direction. It's a quantity that has magnitude and direction, which means that magnitude and direction has important role on that quantity. Magnitude and direction have important role. What does it mean? It means that the magnitude of the vector will change or might change, can be affected by the direction. The magnitude, what is magnitude? Magnitude, we have said that before, is the value of the quantity. For example, now, a force of 50 Newton. Let's say we have a force X equal to 50 Newton. This 50 is the magnitude. Are you getting it now? Now you will be discovering that when this force is directed to another direction, for example, we have a force of 50 Newton here, F to be equal to 50 Newton. Right? Let's say this 50 Newton is directly upward. Right? Now, if you are taking this 50 Newton, which was directly upward, to a inclined direction, you will discover that the 50 will change. Are you getting it now? The 50 what will change? The magnitude will change. It will no longer be 50. Are you getting it? This is what we call vector quantity. Magnitude affects vector quantity a lot. Direction affects vector quantity a lot. So we can now say, we can redefine vector quantity, listen very carefully, as quantity that has both magnitude, and direction. So what are the examples of vector quantity? An example of vector quantity is velocity, displacement, force, weight, as we have said earlier, weight, acceleration, momentum. That momentum, we have electric field intensity. ITY, electric field intensity, etc. Those are examples of vector quantities. It means that those quantity velocity will change magnitude with direction. It has magnitude and direction. Displacement has magnitude and direction. Force has magnitude and direction. Weight has magnitude and direction. Acceleration has magnitude and direction. Momentum, electric field intensity, they all have both magnitude and direction. Now, what we'll be talking next is how to add, subtract, or do vector operation. Now, remember that in scalar operation does not matter, because in scalar you just add or subtract depending on the question. But in vector, it is very important. Vector addition is very, very important. For example, now when we have 5 Newton to the east and 17 Newton to the north, to the east, and we have 17 Newton to the north. To add this, you don't just say 50 plus 70. If you do this, you are wrong. It is not correct. To do this, you have to use a method that we will be describing in the next class. Do you want to know the method, or should I complete it? Don't worry. Watch the next video on vector operation. In that case, I will be talking about how to add, subtract, or do operations on vector. But remember that operation of vector depends on the direction in which the vector is going to. Thank you very much. Make sure you like and subscribe this video, because what I am releasing here are exam bullets.